Very good morning. First of all, I am telling about myself. My name is V Rangaiahchari from Department of Computer Science and Engineering in Mallareddy Engineering College for Women Campus. Today I am discussing the topic about the data structures. Generally, data structures means combination of algorithm and structures to form a program. In few more definitions we get data structures. Data structures. Data is nothing but elements. Structures to store the data and organize data. Not only store and organize it, we can more operations like processing and re-verifying those data. So data structure is equal to a container for stores the data, like that, like a memory to store that data. Next, data structure, it represents like this: algorithm and combination of data structure is called to form a program. That program is maybe either C, Java, whatever. Any programming language like follows this manner. Next, types of data structures. Data structures are classified into two types. First one is primitive data structure. Second one is non-primitive data structures. Data structures are classified in this way. We can follow some rules. Non-primitive data structures are again divided into linear data structures and non-linear data structures. First one, in primitive data structures, these data types are must and should. These are fundamental data types to every language, like integer numbers, float numbers, character data type. Integer numbers is nothing but like normal numbers. Suppose we are giving in programming language like variables, a is equal to 1, 2, 3, like that manner. We want to give values to that programming, we need to use that integer data type. Not only integer data type, like different values, like decimal values, we need to use float A, float B, float C, that type. Similarly, character is also one of the data type. It is used to give the characters to the computer, so we need to use that type character. Next one, non-primitive data structures. Already we know non-primitive means it is developed by the using primitive data types. Already we know primitive data types are fundamental data types. So like in English, alphabets. By using alphabets we can generate the words. Similarly, non-primitive data structure also developed by using the primitive data structures. Non-primitive data structures are in this way, like examples, arrays, structures, and some more. Here, arrays. Array is also one of the non-primitive data structure. It is implemented by using primitive data structures. Here, linear data structures are classified like examples, stacks, queues, linked list. Similarly, non-linear data structures. Already we know linear data structures, data or elements stored in linear format or sequential format. So stacks, queues, linked list, all those are followed linear format, sequential format to store the data in computer's memory. Next, non-linear data structure. Already just now discussed non-linear, non-sequential manner, like examples of these trees and graphs. These trees and graphs follow non-linear data structure to store the data. Next, classification of entire discussion topic. Data structures, which is classified into two parts: linear data structure, second one non-linear data structure. Already we have seen linear data structures are classified into two types: static data structures, dynamic data structures. Already we know static data structures is nothing but like arrays. Static data structures like arrays. In that arrays we have one drawback. Once we initialize that size of array, we can't increase the size of array once after this initialization. This is the biggest drawback. Not only that drawback, once we mention that size, we can't add some more elements. At the same time, once we mention that size less than those values, that is also drawback. So memory problem is the biggest problem in static memory allocation. Similarly, in dynamic memory allocation, it overcomes the drawback of static linear data structure and also like array data structure. To overcome this by using dynamic data structure, it is also called as dynamic memory allocation. Dynamic data structures are again classified into linked list, queues, stacks. Similarly, non-linear data structures. Non-linear means data is stored in sequential, non-sequential, different format follow. Like examples of trees and graphs. Linear data structures. Already we know linear data structures. Linear means storing the data in computer's memory linearly. At the same time, accessing also like sequential. However, the elements can be stored in this data structure in any order. Storing the data in any order. Examples: stacks, queues, lists. It is the example of linear data structure. Suppose I am giving some values like 3, 8, 1, 0, 5, minus 2, 32. These are given in the form of array. Already we know arrays are storing the elements by the index starts from 0 and ends with n minus 1. Here I am taking 7 values. So first value storing the index of 0, final value like n minus 1. 7 minus 1, 6. 6 is the final index. Next, linked list representation. Elements are representing in the form of linked list. In linked list, elements are represented by using nodes. Already we know node is nothing but a storage. It contains two fields. First field stores the data element like values. Second field stores the address of next element like address. Like it is a pointer concept. Next, this is the structure. It is used to stack memory. Arrays are using like stack memory. We are inserting these values into the stack memory. Here, like in linked list, it follows the queue. In queue, inserting one end and deleting another end. Non-linear data structure. In non-linear data structure, the elements in hierarchical order. Hierarchical means like different strategy. Elements of non-linear data structures are stored and accessed in non-linear, not in sequential. Different times we can access those elements. Examples are trees and graphs. Examples of non-linear data structures are trees and graphs. Already we know tree. Tree is nothing but like normally it is a root and separate branches. Here we are also inserting elements in computer's memory in the form of tree. In the form of tree, the first element is called root node. It is the first node of the tree. Next, after that, two elements are coming like B and C. These are the siblings of A element. So first element is called root element. That element goes to level 0. After that, B and C, those elements are called moves to level 1. Those are called B, C are the siblings of A. Here B again classified into like two nodes D and E. These are the child nodes of parent node B. Similarly, D also dividing H comma I, E also dividing J. Here one more subtree is formed like previously, root node, left node, right node. So finally tree follows root node to leaf node. So if the node does not have any node, that node is called leaf node because of it does not have any node. Similarly, graph also follows. Similarly, graph also follows that same rule. Here graph is a collection of edges and vertices. So here also we are forming a graph. In the graph, A, B, C, D, E are the vertices. These are connected by using that edges. Stack. It is the example of non-linear data structure. A stack is a linear data structure that follows the principle of last in, first out. Last in, first out. Real example of placing of books one by one. We are placing that first file removed last time. Last file inserted, we will remove first time. This means that last element is inserted inside the stack is removed first, like previous example. It has only one end for inserting and removing items. Like inserting one end, removing another end. Both ends, both are processed at a time, not possible. LIFO principle of stack. LIFO or one more FILO. Last in, first out, first in, last out. Both are same. In programming terms, putting an item on top of the stack. So inserting new element, that is called top of the stack. Removing an element is called top of the stack. This is the example of to insert and remove elements of stack. So these are called stack operations. Suppose consider it is the empty memory in computer. It is empty stack. Suppose I am inserting first element number 1 into that memory. After that we are every time inserting element. That operation is called push operation, like this wise. I am inserting 1, in second step 2, 3, like this. Suppose I want to remove that one, we need to last add element to remove first. So insertion doing one end, removing doing another end. So both operations cannot do at the same end. These are the basic operations of stack. Already we have seen last slide, push, pop. Here few more concepts like is empty, is full, peak. Is empty. Already we seen push, adding a new element to the top of the stack. Next pop, removing element from the top of the stack. Is empty. Check if the stack is empty, whether the stack is full, like at least one element or not, to check that purpose. Is full, completely filled with memory or not. Peak, get the value of the top element. Top element means what is the last inserted element. We need to check that. We need to use peak element. Working of stack and data structure. The operations work as follows. Pointer called top. It is used to keep the track of element of the top of the stack. Like checking the top value of that stack. Similarly, when initializing the stack, we set its values to -1. Suppose if the stack is full, to check whether it is full or empty, we need to use that time 0 or -1. Like we can check if the stack is empty. Stack is empty, comparing with the previously initialized -1. Okay, next slide. Next class we will see that next topic.